Okay. So good afternoon, everybody. Let's start. So last time I started to teach, let me see if the mic, yeah, I think the mic should be okay. Yeah. So last time I started to teach another, a second type of, second kind of interrupts, Rti, okay? And very simply, what is the difference between IRQ and Rti? Very simple. In IRQ, as I explained last time, for IRQ, you have external pin here, which is BE2. BE2 or BE1? Okay. BE1, I'm sorry, BE1, the second one here. So it's a port E, pin number 1, PE1. So PE1. Okay. You have a pin here. Every time there is a falling edge coming for, or zero, okay, it means how you program it. So you are going to have interrupt. As I told you, this falling edge can come from a sensor. Tomorrow in the lab is going to come from a switch, whatever, okay? So today I'm going to teach a different type of interrupts. This one is called Rti, or this is timer. This is actually timer. The main difference between these two, they are completely different. So here in Rti, number one, there is no external pin. So this one doesn't need external pin. This one is a timer. You got what I'm saying? So it's something internal. So this is a microcontroller. We have CPU here. And then you connect a timer here, you connect a timer. So all what you have to do, I have to set the time out of the timer. So I'm going to tell the timer, interrupt me every 10 milliseconds or every 20 milliseconds and so on. So what's going to happen here, this timer is going to make interrupts every 10 milliseconds or 20 milliseconds. So Rti is used, don't be confused, there is no external pin. This is a different thing. Rti is used if you need periodic interrupts. Okay, give me application. How I may need periodic interrupts. We need to generate periodic interrupts. Okay, we already did something like that. For example, as I'm going to elaborate today, if I want to do a flashing LED, if I want to do a flashing LED, guys. Okay, I want to turn it on off every 1 second. How I already explained in chapter 3 how can we do it. I did it in the main program. Today that's what I'm telling you. The same everything I taught in chapter 3, you can do it in chapter 4, but using interrupts. You got what I'm saying? That's why the same task. It's up to you. You want to put it in the main program, it's okay. You want to put it in interrupt, it's okay, right? So, however, a general advice, interrupt, you should do your best to reduce the amount of code in any interrupt subroutine. You know why? So, for example, if this is the main, I want a microcontroller to go execute a subroutine and come quickly. Any delay or any extra time here is going to impact the performance of the whole system. Why? Because remember, when I execute one subroutine, there is a task here. I hold this task. I suspend this task. Also, I'm not going to respond to other interrupts. That's why usually you have to be very careful. Maybe it's not in this course, but in real applications, you have to be careful. You should not write too much code here. You should not spend much time in any subroutine, because if I spend too much time here, so this is going to impact the other tasks. Anyway, so what I'm saying here, guys, I'm just giving you example how I'm going to give you example for two applications how I need periodic interrupts. Okay, for example, if I want to do a flashing LED similar to what I did in chapter 3. Okay, so all what I need, guys, I need interrupts every 1 second. For example, imagine if I can do something like that. I have interrupts every 1 second, right? And then in the interrupt subroutine, I'm gonna write here flip LED. That's it, one line. You will see today how this is the code much easier than what we did in chapter 3 because of using interrupts. Interrupts can make things easier because most of the work are done by the hardware. I'm not gonna write a code to count for 1 second, right? The counting is gonna be done by an external circuit, by the timer. You got what I'm saying? So here, that's all what I can do. So every interrupt, I'm gonna flip LED, and if I can, if I set the timer to trigger interrupts every 1 second, what it means? What it means you trigger interrupts every 1 second? It means every time you trigger interrupt, actually you execute a subroutine. That's it. So I have a subroutine, and this subroutine is gonna be executed automatically every 1 second. Okay, very easy thing to do. Also, if I want to do a buzzer, like I want to do alarm as we did in chapter 3, if I want to do alarm like this one, alarm, to do the alarm, it is just you generate a square wave as I explained in chapter 3, so it's periodic also, same thing. So still I can use Archi to do that. But you have to adjust the time. Okay, so for example, if you flip BT5, you remember the buzzer was connected to BT5. So if I write here in the subroutine, flip BT5. Okay, so every interrupt, I'm gonna flip BT5. But I'm gonna, as you remember, the time here, I think it was 2 milliseconds in one signal, and the other signal was 1 millisecond. So very simple. So all what I'm gonna do, I'm gonna say, I need interrupts, for example, every 2 milliseconds, for example. And every 2 milliseconds, I'm gonna flip the BT5, right? But if I do that, I'm gonna get only one, I'm gonna get only one tune, like one tune. You got what I'm saying? So if you want, if you still you can do two tunes if you want. Okay. So but you have to write code. So you can write some code here so that after a certain time, I'm gonna change the time from 2 milliseconds. I'm gonna make it 1 millisecond. You can do that as well. Anyway, so I'm just giving you examples how Rti can be used. In general, Rti can be used if you want to generate like periodic, if you want to do something periodic. Okay. So now I'm going to give you details about it. And as I told you, for any interrupt, I'm going to explain, guys. Number one, I have to explain. Number one, how can you initialize the interrupt vector, similar to what I did before. So it's exactly same thing like what when I explained to IRQ. I told you here in IRQ, you can put the subroutine anywhere, but you have to tell the microcontroller where is the subroutine. So you have to use this number here. I have to store the address in this location. Okay. Same thing. I'm going to repeat it right now. However, I'm going to use a different number for Rti. So if you go to the table, I'm repeating this part. I already explained it. So if you go to the table here, you have to use this number instead of this number. Is that okay, guys? Very easy. Very easy. Same thing. I'm going to do it with channel 4, but I'm going to use this number. Same thing with this one, but I have to use this number and so on. That's it. So all what you need to do, you can put the subroutine anywhere, but you have to put the beginning address in this location, predefined location, just to tell the CPU where is your subroutine, where is the interrupt subroutine. Okay. So I did it here. So this is what so this is the name of the subroutine, guys, as you see here. You can call it any name, but I'm going to call it Rti underscore interrupt subroutine. And then here I'm going to use FF0. So you have to use this one in your program, as I mentioned before. This is number one. Number two, for any interrupt source, there is a bit. Is this bit for enable or disable? You have to tell me where is this bit. For IRQ, this bit was in this register. Yeah, in this register, it was this bit, right? Yeah, this one. One for enable, one for disable. Is that okay? So same thing right now. So for enable, for the enable bit is which one? Yeah, this one here. In this register, CRGINT. Okay, this is bit number 7. So I don't care about the other bits, just I care about this one. This is for enable or disable. So if I want to enable Rti, all what you have to do, guys, I'm going to put 1 here. If I want to disable Rtis, all what I'm going to do, I'm going to just put 0 here. That's very simple. That means if I want to disable Rti, this is the initialization. That's what I'm going to do in the beginning of my program. I'm going to say bit set CRGINT ET. So in order to put 1 here to enable interrupts for Rti. Is that okay? So this is the initialization. It's the very beginning I'm doing. However, tomorrow I'm gonna ask you to disable Rti at a certain point. So how can you do that? Very simple. And instead of using bit set, so you can use bit clear. That's it. You put 0 here. Is that okay? What it means? Okay, so what it means you disable Rti. What it means? I'm gonna tell you what it means. Look here, guys. Rti is going to do flashing, right? So because every 1 second you are going to flip the LED, you are going to do flashing. Is that okay? So if you disable Rti, it means I'm not going to execute the subroutine. Even if you trigger interrupt, I'm not going to execute the subroutine. That means there is no flashing. Very simple. So that means you suspend or you pause or you stop the task, whatever the task is. You got what I'm saying? So if Rti is used to make a buzzer, to make alarm like this one, as long as it's enabled, you enable the task, you enable the alarm. Same thing for flashing. So that's what you should understand. When you disable Rti, it means you are not going to call the subroutine. That means the task Rti is doing, you are not going to do it. So there is no flashing. Okay. So this is another thing. Okay, what else I have to do to program Rti? To program Rti, always look here, guys. For any interrupt source, I have to tell you 2 things. Where is the enable bit? Okay. Number 2, I have to tell you where is the interrupt flag bit. Do you remember the interrupt flag bit? Okay. This is where is the device? If a device want to trigger interrupt, it has to put 1 here. Okay. To trigger interrupt. This is something when you want to interrupt me, you have to raise your hand. Is that okay? And then it's your responsibility, and this is very important, as I mentioned several times. In the interrupt subroutine, in the Rti interrupt subroutine, you have to write a command here to clear it, to put 0 here. Why? Because I already served the interrupt. So I have to put 0. You got what I'm saying? So that if there is a new interrupt in the future, it's going to put 1 here. Okay, so every time there is a 1, that means there is interrupt that's not served. Once you serve the interrupt, you put 0. Okay, and again, the word serve the interrupt, it means you execute the subroutine of this interrupt. That's why always in the interrupt subroutine, you have to write a command to do that. And this is so number 1, where is this bit? I'm going to tell you where is this bit. This bit is here, CRG, FLG, bit number 7 as well, this way. Okay. And the way you have to do it, you have to use this instruction. Okay. In order to clear, you have to write 1. When you write 1, you clear it. Okay. So this is how it works. So very simple. Don't think about it. All the time in Rti subroutine, you have to copy this one and put it here. You're not going to change it. All the time you have to put it in order to clear the flag bit. Is that okay? So okay, what else we have to do? So you told us, number 1, I have to program the interrupt vector. That's true. Number 2, I have to program enable. Yes, this is the second one you do. Very simple. Bit set for enable, bit clear for disable. Okay. Number 3, you have to use this one inside the interrupt subroutine. Is that okay? What else? Again, remember, we didn't do this one in IRQ, as I mentioned last time, and this is the only exception. The only exception is IRQ. It is done automatically in IRQ. But when I explain the timer in chapter 5, for any other interrupt, you have to write it. Okay. So what is missing here? Only one thing is missing: configuration. So what kind of configuration I can do here? Okay. Remember, in case of IRQ, the configuration was, do you want to trigger interrupt when it is falling edge or it is 0 level? So you have to select this one or this one. This is the kind of configuration we have. However, here's the timer. The configuration is different. The configuration here is you need to set the time. So I have to write a comment. I have to tell the timer, please interrupt me every 10 milliseconds, every 1 millisecond, every 5 milliseconds. So you have to write a command to set the time out. Okay. So how I can do that here? The way you are gonna do it is, look here, guys. We have this register Rti CTL. We have this register Rti CTL. You have to put some number here. Okay. So every time has a number. Just to put the number here. Okay, so how can you come up with this number? I'm gonna tell you how you can come up with this number. Look here, guys. So here, the first 4 bits from 0 to 4, the first 4 bits, this part here, these 4 bits, I'm gonna call them N. And the 3 bits here, this one is always 0. Bit number 7 is always 0. So the first 4 bits, I'm gonna call them N. And these 3 bits I'm gonna call them M. Okay, so these 4 bits. Okay, so now for every time there should some value for N and some value for M, right? All what you have to do, You have to know what value and just write it in this register. Very simple. For example, here, I found is a value to make interrupt every 131 millisecond. Every 131 millisecond to make interrupt. All what you have to do, I have just to write this number here. That's it. If you need a different time, you have to put here a different number. So the question is, how can you come up with this number? That's what I'm going to explain now. Okay. So the way you have to come up with this number is, I told you we have here N and M. Okay. N, if you look at this table has all possible cases, all possible cases. So M can have a value from 000 until 111 because M is 3 bits. N is 4 bits. So it has 16 value from 000 until 111. So here in this table, I give you all the possible cases in this table. Okay. So only what you have to do, for example, if I select this one, guys, here, or let's, for example, I'm going to select this one here. Okay. So here, if you wanna select this one, so this value should be M and this value should be N. That means, let me come back here. It has to be 111111. This number is 7FH. Is that right? 7FH. Sorry, hexadecimal. 7F. And this is the exact number I used here, 7F. Is that okay? So now, what this number is? So now how you have some numbers here, how you convert these numbers to time, It's very simple. Look, there is some equation here, guys. This is the equation here. This is the time in microsecond. It should be the value of n plus 1 times 2 to the power of m plus 9 divided by 8. Okay. The table here, this table is going to give you this value here. So this value is in the table. So all what you have to do, guys, here for any value here, take this value divided by 8 microseconds. That's it. Okay. So that's what I did. So if I take this value here, I'm going to divide it by 8 because this value is actually this part here. This is what you have in the table. You just divide it by 8 microseconds should give you 131 milliseconds. Okay, listen to me, guys, for what I'm going to say right now. This timer is a very simple timer. As the way you are going to select the time is somehow complicated because you have to look at the table. It's not that easy. However, in chapter 5, I'm gonna teach a timer system, very advanced timer system. The way you are gonna select the time is gonna be much better than what you have here. Again, what you have here, you have just some values. You have to pick up one of these values. You don't have all the numbers. However, as you will see in chapter 3, we have like a more advanced timer. This is like, you can think about it like this is a simple timer system. Okay. So anyway, but don't worry. Maybe, yeah, but it's too much numbers. Don't worry. Most of the time, I'm gonna take this one or this one. If you want to take any other time, that's okay. But you need to convert these numbers. Okay. Again, you have to divide it by 8 microseconds. That's it. Again, so let me summarize what I want to say here, guys. Look here, guys. This table gives you all the possible time out. Okay. So for example, I'm going to pick up this one. Okay. So number one, how much time here? How much time out here? You have to divide it by 8 microseconds. Okay. Because the number I'm giving you to here is gonna be this part here. Okay. Anyway, and then, so if I want to program it to have this time, all what I have to do, I have to put this value in M and I have to put this value in N, whatever the value is. Okay, and this is M. This is M. N is here. M. Sorry, the first 4 bits are N and M is here. Is that okay? Very simple. Let's have another this example here because most of the time we're gonna either use this one or this one. Okay. For example, let's use this one. So all what you have to for this one, I told you the number is 7F. So if you want to program it so that you can have a delay, you can have time, you can have interrupt every 131 milliseconds. So you have to put 7F here. Okay, that's easy. So now, what if I wanna have a delay? I wanna have interrupt every 10.24 millisecond. What I can do? Very simple. So you have to put this value in M. You have to put this value in N, right? So it has to be what number is that? Let me go. So it has to be. So again, these four are N. These three are M. Okay, so what is in here? So M is 100. Okay, so it has to be 100. Is that okay? This is for M. For N, it is 1001. So what this number is? This is 4. This is 4. This is what? 4A. For what? So 1 and 49, I guess, right? So this is 9. So all what you have to do, you have to send this number 49. Is that okay? This is 124, yeah, 49. So all what you have to do, instead of writing 7F here, write 49. That's it, very simple. You got what I'm saying? Anyway, again, the way you are gonna set here the time out is not the best way. I know that, but again, in next chapter, I'm gonna teach another timer system. It's much better because here you don't have too much flexibility. Okay, all what you have to do is just have a certain numbers. You can just pick up one of these numbers. Okay. Anyway, any questions? Okay, so now let's see the program. How I can now I want to make a flashing LED. How I can do it? Okay, but I want to write the code in the. I want to use Archi to do the flashing LED. How I can do it? Look here, guys. Number one, I have to write this one. This is all the time you have to do it. This is similar when you program port H as input. So all the time there is a code, I'm not going to change it. All the time I have to put it in your program. Same thing here. This one, all the time, as long as you have Rti, you have to put this one. Okay, this number one. Number two, here, you have to enable all interrupts. You have to enable Rti interrupts, as I explained. So you have to do this one to enable interrupts. Now, I want to do flashing every 1 second. That means I need interrupt every 1 second. So I need interrupt here, and then I need another interrupt every 1 second. Is that okay? So that I'm going to flip the LED every 1 second. Is that okay? So what number I have to use here and put it in this register RTICTL to make interrupts every 1 second? We don't have. Why? Because if you look at the table here, 1 second is a very long time for microcontrollers. The maximum delay you can get, the biggest number, the longest time out you can get is only 131 millisecond. You cannot get more than that. Again, because 1 second is a very long time. Okay, so how I can solve this problem? Again, what is the problem? The problem is, in order to make a flashing LED every 1 second, as you see here, I need interrupts. I need interrupts every 1 second. Is that okay? However, the maximum time out I have is only 131 millisecond. You got what I'm saying? How I can solve the problem? It's very simple. How it is very simple. Look what I'm gonna do. I'm gonna trigger interrupt. This is the maximum time I have. This is the longest time out I have. It's gonna be every 131 millisecond. So I'm gonna trigger interrupt every 131 millisecond. Is that okay? However, I'm gonna flip the LED every 8 interrupts. Not every interrupt, every 8 interrupts. Why 8 interrupts? Because 8 times 131 is around 1 second. You got what I'm saying? So what's gonna happen? I'm gonna have here interrupt. Okay, this is interrupt number 1, do nothing. I'm gonna just count. Interrupt number 1, do nothing. But after 131, so interrupt number 2, do nothing. Interrupt number 3, do nothing. Until I reach to interrupt number 8. At interrupt number 8, flip the LED. So I'm gonna flip every 8 interrupts. Is that idea is clear? Okay, now, if you wanna do flashing every half a second, how I would do it? Instead of every 1 second, half a second, how I can do it? It's exactly same idea. However, I'm gonna flip the LED every 4 interrupts. So 4 interrupts, because I'm gonna have here 131 millisecond. The time between each 2 interrupts is 131. So 4 interrupts should have half a second. Should be half a second. Same thing. If I want to make interrupts every 2 seconds, so I have to count for 16 interrupts. You got what I'm saying? That's it. Clear? Very simple. So all what I'm gonna do, guys, if there is interrupt, I should have a counter. I should have a counter to count. This is interrupt number 1, number 2, number 3, number 4, and so on. And then I have to take action at a certain number. And then you have to clear the counter again, as we see right now. So look here. That's what I'm gonna do right. So now I finished the initialization this way, guys. This is the main program. This is the main program. And then, because this is just a very simple program, I'm gonna keep looping here. So because there is no task, I'm not gonna put a task here again. This is just because this is a very simple program. In reality, you may have a task here, but anyway. So just I'm gonna keep looping here. Every time there is an interrupt, I'm gonna go execute the subroutine, come back, go execute the subroutine and come back, and so on. Okay. So, and now look at the subroutine here, guys. Number 1, this is the interrupt subroutine. You have to use this name. You can use any name, but yeah, whatever name you put here, it has to be the same name you put here. So you can put any name, but it should be the same name here. Okay. So, and then as you see here, guys, you have to end it with this subroutine with Rti, as I told you. Then also don't forget to write this one. This is to clear the flag, as an interrupt flag bit. Someone can ask me, should I put it at the beginning or at the end? It doesn't matter. It doesn't matter if it's the beginning or it doesn't matter. Okay? Because if you remember what I explained interrupts, once you go to the interrupt, automatically all other interrupts are disabled. You got what I'm saying? So, but let me tell you my advice. Sometimes it matters. For our programs, it may not matter if you put it at the beginning or the end. Okay? But let's think about it. Maybe it's gonna matter in other programs. You know why? I'm gonna tell you why. So I recommend to put it in the beginning. I'm gonna tell you why. We put it in the beginning so that I'm gonna put 0 in this flag bit. Okay? So that if there is another interrupt when I execute this part of an instruction, it's gonna be recorded because I cleared it at the beginning. You understand what I'm saying? Assume if you have very quick, again, this can happen only if you have very quick interrupts. Right? So if you have very quick interrupts, for most of our programs may not be a big deal, but what I'm saying is it may not matter if you put it here or put it here, but my advice just to put it here so that you put 0 here at this point, so that if there is any interrupt, it's gonna come before you clear it. So here at any time here, if there's an interrupt, it's gonna be recorded, so that when you go to the main program, you are gonna capture this interrupt. However, if you do it later, for example, this one is 1. And then I'm gonna write this one at the end here. Okay. So if another interrupt came here, you are gonna again write 1 here. So I'm not gonna capture it. So you are gonna respond only 1 time for 2 interrupts. Anyway, this is a very simple difference. I think only you are gonna have this problem if your interrupts you have very quick interrupts. Okay. Anyway, so just put it in the beginning. It's okay. You clear it. You clear the flag bit so that if there is another interrupt, it should be recorded here. But you are not gonna respond to this interrupt until you leave. You go to the main program. So if it happens once I go to the main program, I'm gonna come back to here. You got what I'm saying? Anyway, so number 1, you have to clear the flag bit. You have to end it with Rti, as I told you. Okay. Number 2, what else you have to do? Very simple. I have a counter. I need to count this interrupt number 1, interrupt number 2, interrupt number 3. So this is the counter here. So here I define a variable. I define this variable, Archi count. Okay. So every time there is an interrupt, I'm going to increment this counter as you see here. Every time there is 1 interrupt, I'm going to increment the counter. Is that okay? And now I'm going to compare it to number 8. I'm going to compare the counter to number 8. If it is less than 8, what should I do if it is less than 8? Do nothing. Just leave. I'm done. Leave. That's exactly what I did. I'm going to come here. Just leave. Go to the main program back. Is that okay? So for interrupt one, I'm going to come this way, and then I'm going to leave. Interrupt 2, leave. Interrupt 3, just every interrupt, I'm going to just increment the counter and leave, increment the counter and leave until interrupt number 8. Once it is interrupt number 8, I'm going to come this way. What should I do if it is interrupt number 8? Number one, I have to clear the counter to count for another 8. So every 8, I'm going to come here. So you have to clear. I'm going to clear the counter to count another 8. Is that okay? So, and then I'm going to flip the bit here to do flashing. Any questions? That's what you need tomorrow. So what I'm saying, look here, how it is very easy. All what you have to do, guys, is that if you want to, this program, you are going to make a flashing every 1 second. If I just change this number to 4, that means I'm going to flip the LED every 4 interrupts with half a second. Very simple. If I make this one 16, so it's going to be every 2 seconds, and so on. 24, 32, whatever, any number here. Is that easy, right? Any questions? Very important thing I mentioned before, this counter, the counter you have to use here, it has to be a memory location. It cannot be a register. It cannot be a register. Please, if you want to remember anything from the subroutine, it cannot be a register, because as I explained before, automatically all registers, the values of registers are going to be stored in the stack. You are going to get them back from the stack. Okay, so you're not gonna, so all the registers are gonna get the initial value anyway. So if you start from 0, then you are gonna continue 0. After interrupt 1, you are 0. After interrupt 2, 0. After interrupt 3, it's 0, right? Because always you are gonna get the initial value. But for memory location, it has to be a memory location as I did here. Any questions? So interrupts routines don't memorize registers value, because once you write something here in a register, the register is going to get the initial value back. Very easy. Okay, guys, any questions? Okay. So what I'm saying, guys, is that's why I'm telling you it's easy. Now, how for any other program, if I want to use Rti for any other program, how this would be different? Okay, guys, listen to me. Number one. All you just this part, you want to do something else other than what we did here. Just remove this part, write whatever you want to write here. This is one thing. Second thing, you may, if you need a different time, maybe you are going to put a different time here. That's it. Everything else will be the same. You need to enable, you need to do this one. Everything else is the same. That's why I'm saying programming is easy. Once you know how to program only one program, all of them are the same. The only thing you may change is this time. If you need a different time, just put a different value here, and then this part you can write the other program. Okay. Any questions? Okay. Let me show you the video. Do I have a video here? Let me see. Just a flashing. It's not a flashing. It's called flashing. Yeah, LET. Yeah. So this is similar to what we did in chapter 3. But what I did in chapter 3, I put it in the main program. Now I put it in Archi. Is that okay? Any questions? Okay. Now the question is how I can do the same. How I can do the same thing in C language, right? So you will see right now, I want to do the same thing in C language. Look here, guys, in C language, how can you do it? So this is the main program in C language. As I told you last time, this is for any interrupt subroutine. This is the interrupt subroutine. It has to be this way. As I told you last time, guys, you have to use the word void. You have to use the word interrupt. Okay, here you have to use a number corresponding to this interrupt source. If you go back to Archi, it was number 6. Now it is number 7. So from this number, C language. So you have to use this one. You have to use this one. Here, this number should tell the C language what interrupt is that. So always for IRQ, it has to be number 6. For Archi, it has to be number 7. And then this is just a name. You can use any name. Okay. So how can you come up with this number? This is just the number in the table, the number of the interrupt in the table as I explained last time. So for example, here 0, 1, 2, 3, 4, 5, 6. So this is number 6. This is number 7. If you want to program this one, should be number 8, and so on. This is just you can get the number from this table. Very easy, right? So here, yeah. So as you see here, guys, so this is the interrupt subroutine. Just always, I'm going to use number 7 here for RTI. Okay. So now this is main program. Look at the main program here, guys. As we always do that, we initialize PLL, or we set the system to be 24. We always do this one. We disable a 7 segment. We enable LEDs. This is just initialization for the LED I'm gonna use. Always we do that. Okay. Now I want to program similar to what I did here. I want to program the timer. So all what you have to do, guys, we have this one here. We have this again. You can program registers as we did here in C, but you can do it in assembly, or you can use functions. As I told you, in C language, we try to be far from the hardware. I just want to give you functions. So this one, Rti initialization. This one should configure the timer to trigger interrupts every 10 milliseconds automatically. So what this one is doing, this one is gonna put so Rti initialization automatically is gonna trigger interrupts every 10 milliseconds. Okay. What if you wanna again, as I told you before, every function I'm teaching here in C should have a C language. Should have assembly language. So if you go inside this function, you will find I 49. 49 is corresponding to, if I'm gonna write 49 in this register, 49 is corresponding to 10 milliseconds. Is that okay? What I'm saying right now, what if you need to, if you want to do a different number, how can you do that? Very simple. All what you have to do, guys, is also after the initialization here, this initialization should enable interrupts. It should also set the time. So after initialization, you can write something like that. Rti equal whatever, you can put it this way. Is that okay? Rti equal whatever, you can put it this way. It worked with us for most of the students. However, sometimes for some reason in very few boards, for some reason, they didn't accept it. And what we had to do is we went inside this function, we changed the number. We write to the Rti instead of 49, we made it 7F. Okay. One more thing, it may be useful to you. Look here, guys. C language allows you to write some assembly instructions. How? I'm going to tell you how. You can write here inside C language. So I want you to, again, let me just summarize what I said, just to make it easy, guys. What I'm saying is that if you use this one, Rti initialization, if you use this way, okay, you are going to trigger interrupt every 10 milliseconds. Very easy, right? Now, what if you need a different number? What can you do? I'm giving you different ways. See, whatever works for you. One way is just I can write something here. I'm gonna put it here, for example. After initialization, Rti CTL equal whatever the number you want to do. This is one way. Another way, you can go inside this initialization. You will find inside the initialization, this one you will find instruction exactly similar to this one. However, the number here was 49. You can simply change this number 49. You can change it to this value, whatever any value. Okay, because this function is written in assembly. This is the second way. Third way, you can try it. Third way is, that's what I'm teaching right now. C language allows you to write assembly instruction inside the C language itself. Okay, so what you can do is you can underscore ASM, and then you can write here the assembly instruction, semicolon. So what I'm saying, you can take this one, you can put it here inside here. Okay, instead of Rti equal whatever, instead of this one here, if this one works for you, that's okay. I'm telling you, for some reason, in some boards, it didn't accept it for some reason. But I think it should work with you. But anyway, I'm saying if it didn't work, you have also another way. So you can write here, guys, underscore ASM, and then you can say move byte, then whatever 7F, comma, Rti CTL. Okay. So C language allows to write assembly inside it this way. Any questions? Okay. So if you do that, again, very simple. So for initialization, for Rti initialization, guys, very simple. All what you have to do is just to call this subroutine. That's it. That's all what you have to do. Once you call this subroutine, you are going to have interrupts every 10 milliseconds. Is that okay? I'm gonna ask the same question again. I want to do flashing every 1 second. How I can do it? Okay. So similar to what I have just did right now. Okay. I'm gonna count number of interrupts, and every 97 interrupts, I'm gonna flip the LED to do flashing. Why 97? Because if you multiply 97 times this time, is going to be around 1 second. Okay. So if you need half a second, should be half this number. Have this for sure. It's going to be a fraction. So just ignore the fraction. It's not a big deal. So it's going to be 4 for what? 45? Oh no, 40, 46, whatever. 45, 46, I guess. Anyway. So whatever, have this number, whatever, I think 46. Anyway, so for half a second, if you needed 2 seconds, so it should be 97 times 2, whatever it is. Okay, guys. So that's what I did here. If you look here, guys, what I did, inside the subroutine here, I have a counter similar to Rti count. I did here, same thing. I need to count this interrupt 1, interrupt 2, interrupt 3, and so on. So that's what I did. If you look here, guys, here I'm gonna call it tick, just any name. I call it tick. This tick is counter. So every time there is an interrupt here, I'm gonna increment the tick. Then I'm gonna say if tick is equal to 97, I have to flip the LED, and then I have to clear tick. I have to clear it, so that I have to clear the counter to count for another 97. Is that okay? If it is not 97 yet, so you have to clear the flag bit. You can use this instruction to clear the flag bit, and then you leave. Okay, guys. So in the first 97 interrupts, you just increment. You increment this variable, and that you are not going to do this part. You are going to only do. When this if statement is true, only when every 1 second, because it's 97. Again, very simple. By changing this number, you can trigger interrupts every 2 seconds, half a second, whatever it is. Okay, guys. Any questions? Mistake. I'm going to tell you a mistake some student is going to do. Listen to me. This is a very important thing. What a mistake you are going to do. Look here, guys. I need someone to tell me why. Okay. If you understand programming very well, you have to tell me why. Look, what I did here is this variable, I define it here. I define it outside here. That's what we call a global variable. I'm going to ask you a question. If I define this variable, if I define inside here, it's wrong. If I define it inside here, it is wrong. Can anyone justify? If I define this variable inside the interrupt subroutine, it is wrong, and this is a common mistake. If I define it inside here, it's going to be a common mistake. It's wrong. It has to be a global. Yes. That's true.
And also, if you initialize it in the main, then it would be a global variable, which means the interrupt function copy.
That's true. So let me. I'm going to repeat it. Okay, you answered it correctly, but let me repeat it. So if I define here inside the main, there is a rule in C language. There is a rule in C language. If you define a variable in one subroutine, including the main, we consider the main as a subroutine. So if you define it inside the subroutine, it can only be used inside this subroutine. Other subroutine, if I define a variable here, for example, if I integer I, and I use here I, it's going to give you error. It's going to no, I don't know what's I, because it's local. It has to be inside this one. Is that okay? So that's why it shouldn't be here. That's okay. But why it shouldn't be here? Because if I define it here, so I'm going to use it here. So I'm going to use it inside the subroutine, inside the Rti subroutine. So why it's not, why I cannot do it here? Simply because there is another rule in C language. The rule is if you have a subroutine, if you define a variable like, for example, in integer I, once you leave the subroutine, this variable is going to be removed from memory. It doesn't exist anymore. You get what I'm saying? So it's so every time I leave the subroutine, it's going to be gone. So every time I'm going to reinitialize it again. Okay, but that's why it has to be global here. So listen to me. I made it global. Usually I make it global in one of two cases. If I need to use the variable in several subroutines, but this is not our case here, right? The other case is if I want to memorize this value, every time I leave the subroutine, I want to memorize it. And this is what I'm doing here. Okay, guys? Please listen to me. This is very important. This is a common mistake. So in this case, this variable must be global. Any questions? Great. So now, guys, we have a flashing LED. At any moment, if I wanna stop the flashing at any moment, so that means you have to disable Rti interrupts, because without Rti interrupts, I'm not gonna have flashing, right? So how can you disable Rti interrupts? As I told you guys, in C language, all what you have to do, and that's what you need tomorrow. All what you have to do, guys, this instruction here, but instead of bit set, you have to use bit clear. That's it. That's it. So you need to put here 0. That's it. Once you put 0, no flashing. If you wanna do the flashing again, just to put 1. Okay. So once you allow the interrupts, you are gonna see flashing. Once you disable the interrupts, you are not gonna see flashing. This is in general for any interrupt. If this interrupt is doing a certain task and you want to stop this task, okay, disable the interrupts. If you wanna do this task again, you just enable interrupts. Okay. So, and I think that's what I'm gonna do. So what I'm gonna do right now, and this program is important because the coming program, this is the program you are gonna use tomorrow in the lab. The last program I'm gonna teach right now, guys. So now let me tell you what I did. What I did so far, guys, I explained to 2 programs. One for IRQ. Yeah, here. Last lecture, I explained this program for IRQ. What I did here, this is a microcontroller. What I did here, this is PE1. This is IRQ interrupts. I'm gonna connect it like for a push button, for example, PH0. Okay. And don't forget also, this is a common mistake, as tomorrow some students gonna do that. Okay, I told you, and it just happened last time. Some student came to me, they have some mistake, some problem, the push button was not working, and the reason it was not working because I told you here there is one switch, also there is a push button, right? They're connected to the ground. So if you want to use the push button, you have to make the switch. This switch is here. You have to make they are off. Otherwise, if this one is on, so this bit is 0 all the time. So if you press or you don't press, it's not going to make any difference. It's still 0, right? So you have to make sure this one is open. Otherwise, when you press, you are not going to trigger interrupt. Okay, so this is a very important thing. Anyway, so what we did last time, I connected external jumper, and that's what you are going to do tomorrow, so that every time I press a button, I'm going to trigger interrupt. And what we did here in this one, every time there is an interrupt, I shift an LED. Okay. And I think I have a video here for this one. Maybe not for this one, for this one. Yeah, shifting IRQ. Okay. This is last time the video I explained last time, it was shifting LED, but using the main program. So now this is the same program, but using IRQ interrupts. Okay. So every time I press here, you shift the LED. I'm gonna, just to believe me, this is not written in the main program. It's written in the interrupts. I think I have a jumper here. I'm gonna choose a jumper. Hopefully I can. Oh no, I didn't. Okay. but believe me, I did it. But anyway, I'm going to show you in the next program. You will see the jumper. It was right here. Okay, but you are going to see in the next program right now. Okay, so now, so this I already explained this program. I already explained another program right now is using Archi to flash LED. What I'm going to explain right now is I'm going to put these two programs together. How? I'm going to tell you how. So now what I'm going to explain, and it's very easy, by the way. I'm going to use IRQ plus Archi in one program. I'm going to use both of them. It's not difficult. You know what I'm going to do? Number one, I need this initialization. Okay, I'm going to put it. I need another one for Archi. Yes, I'm going to do it. So I'm going to put both of them, right? Number two, I need this one for IRQ. Okay, I'm going to put it. Also, I have initialization for Archi. I'm going to put it. That's it. So I'm going to put the two initialization. Okay, so as you will see right now. Okay, so now what I'm going to teach now, guys, and this is the program you have to modify tomorrow. Tomorrow lab is very easy. Okay, because you are complaining about ECE. So tomorrow program should not take more than 5 minutes. It's just very easy. I made it very easy because this is the first one is about this is the first program about interrupts. So I want to make sure you can do it. So tomorrow's program, I'm going to teach one program right now that has both IRQ and Archi. Okay, I'm going to ask you to modify these programs. Very, very simple, but it shouldn't take 5-10 minutes. Okay, but I just want to make sure you are comfortable, you are confident in using interrupts. Okay, so anyway, so now that's a program I'm going to teach right now. It's going to have, I'm going to just merge these two programs together. The flashing LED plus the Archi. I'm going to tell you what I'm going to do here. Okay, and you should understand this one because tomorrow's lab is going to be simple modification to this one. So that's why number one, this is the way you have to do the lab. Number one, run this program, make sure it's working, and then modify it. Why you have to do this way? Because once you make sure this one is working, that means all interrupts are working, Archi is working, everything is okay, and then you can modify it. It's going to be very easy, right? If you do this way. So what I want to do right now, guys, is number one, I want to do flashing LED, similar to what I did right now. It's the same program I explained right now. I'm going to do flashing LED using Archi. So Archi is going to do the flashing. Okay. But IRQ should, what IRQ should do, you can stop, you can turn the flashing on or off using IRQ. So I have here a button. Every time I press the button, if flashing is on, when I press the button, flashing is off. You got what I'm saying? When I pull it, if it is off, I press the button, it should be on, and so on. Okay, how can I do it? Okay, let me say it again. Number one, RDI is doing flashing. Okay, flashing is done by Archi. This is exactly the same program I have taught right now. Yeah, exactly same thing. That's okay. Now, IRQ. If flashing is working, I press a button, no flashing. Press the button again, flashing is going to work again. Okay, you know how I'm going to do it? Very simple. The way I'm going to do it is inside the IRQ subroutine. Inside the IRQ subroutine, there is one bit to enable or disable Archi interrupts. One bit for enable or disable Archi interrupts. I'm going to flip this bit. That's it. When I flip this bit, if interrupts are on, I'm going to Archi interrupts are on, I'm going to make them off. If Archi off, I'm going to make it on. Very simple. You got what I'm saying? That's what I'm going to do right now. So I'm going to write it here inside IRQ. So what I'm saying is that every time I press the push button, you are going to trigger IRQ. IRQ is going to flip the enable bit of Archi. You got what I'm saying? To turn the flashing on and off. Okay. Anyway, very simple. So let me choose a program here. How can you make it? Okay. So as you see here, guys, this is, you have to use this one for Archi. Okay. Here I'm showing what should I modify, how I modified the last program I have taught right now about the flashing LED. So I have to add this one. So this is, so now I have to put two orgs, one for Archi, the other one for IRQ. And if you have more interrupts, you have to add more orgs. Very simple. Okay, so this is number one. Number two, because I'm going to use the LEDs, so I have to do initialization for the LEDs. Okay, that's what you have to do. Okay, now also because I'm going to use the push button, I have to configure port H because I'm going to use the push button port H. Also, you have to connect external wire. So here you have to connect external wire between PH, whatever, which you can use PH 0 to 4, whatever you like. Okay, you have to connect external jumper to IRQ. Yes, so that when I press the push button, you trigger interrupt. Okay, so here look, try to see how many ports we are going to use. I'm going to use port B and J for LEDs. I'm going to use port P to disable 7 segment. We always do that. I have to configure port H for the LEDs. Okay, and then also now I have to configure interrupts as well. So now I have to write this one for IRQ interrupts. Okay, I have to do this one for IRQ interrupts. I have to write these two. For Rti interrupts. Is that okay? And then I have to enable all interrupts here, and that's it. Very simple. I didn't do anything. I just got the initialization of IRQ, the initialization of Rti. I put them together. That's it. Make sense? Any questions? Very easy, right? Okay. Now the two interrupts are going to work. One interrupt Rti is going to work periodically. The other interrupt is going to work every time I press a button. You are going to trigger IRQ. Both of them are going to work. Okay. And now, what should I write in Rti? Okay, nothing. This is what I have just taught right now. Rti is going to do flashing. That's it. Exactly same thing. Every time you are going to increment Rti count, if it is not 8, do nothing. If it is 8, you have to flip. You have to flip the LED. Also, you have to clear the counter. No, nothing is new. This is exactly same thing. Okay. Now, what should I put here in IRQ, guys? IRQ. You remember the debouncing I explained last time? The debouncing. Is that okay? So I'm going to write the code for debouncing. Okay. And then I'm going to flip the flag bit of Rti. What is the the enable bit of Rti? What is the enable bit? If you remember in this register, CRGINT, if I go back, this bit is here. All what I'm going to do, I'm going to just flip this bit. Okay, so the way I did it, as you see here, guys, I'm going to read the register. I'm going to flip the last bit in register A, and then I'm going to write it back. Okay. That's why when I press the button, okay, I'm gonna if it is on, I'm gonna make it off. If it is off, I'm gonna make it on. Just flip the bit. You got it? So I'm gonna choose a video here, and I promise this time you will see the wire, the jumper. Okay. So tomorrow you are gonna start with this one. You are gonna do very simple modification on this one. Yeah. So flashing is working. Once I press the button, no flashing. As you see here, no flashing because there is no Rti interrupts. Now Rti interrupts is working back. No flashing. This is the one. This is a jumper. I did it at my home. I didn't find a good wire, so I just did it. It's very simple. That's what I found at my home, but you know, it's not very nice one, but this one. Okay. Anyway, okay, guys. So tomorrow, how we are going to modify this program? I'm going to tell you how. Okay. So what's happening here is. Every time I press IRQ, you are going to turn on or off. You are going to flash it on and off. So what I want to modify this program a little bit so that I'm going to have 4 tasks. Is that okay? Every time I press the push button, you are going to move from one task to another. I'm going to have 4 tasks. Okay. So now if I'm at task 1, when I press IRQ, I'm going to move to task 2. If I'm not, right now I'm task 2. When I press the button, I'm gonna go for task 3. If press the button, you are gonna go to 4. Once you are 4, you are gonna go back to 1. You get what I'm saying? So every time I press the button, I'm gonna move from one task to another. Once if I'm 4, so after 4, I have to come to 1. What every task has to do? Very simple. Task 1, I think is gonna do flashing every half a second. Task 2 is going to do flashing every 1 second. Task 3 is going to do flashing every 2 seconds. Task 4, no flashing at all, it's off. You got what I'm saying? Okay, so let me read the lab quickly. Okay, guys, that's exactly what I said here. Okay, so here, what I'm saying, we have 4 tasks. The first task here, if you are running task number 1, so LEDs, so you have to do flashing every half a second. Remember, half a second means every 4 interrupts. Okay, if you are in task 1, you have to do flashing every 1 second. It means every 8 interrupts. If you are in task 3, so you have to do flashing every 2 seconds, which is 16 interrupts. If you are in number 4, so no flashing. After 4, if I press again, so after 4, I have to go back to 1. Is that okay? So how can you modify this program simply? Very simple. I'm going to tell you how. So look here, guys. What I did here in this program, I'm going to compare to number 8 here. So every 8 interrupts, because here in this program, you are going to do flashing every 1 second. So every 8 interrupts. All what I'm going to do here is, instead of number 8, I'm going to put a variable here. Variable. And this variable should be determined by IRQ, depending on the task. You understand what I'm saying? So here, I'm gonna flip it, not every 8, but every variable. Is that okay? And if I'm in task 1, IRQ is gonna put in the variable 4. If I'm in task 2, IRQ is gonna put in the variable 8 or 16. If I'm in task 4, so IRQ has to disable flashing, to disable Archi. Is that okay? Anyway, I think it's pretty simple. However, the variable you have to use in C language, you have to make sure this variable is global. Why? Because this variable should be used by the variable I'm going to use in IRQ. It should be Archi need to access it. Archi need to access this variable. So that's why it has to be global. Okay. Anyway, so now I want to choose a sim program, but using C language. So that's a very easy program. I just made it easy intentionally because just the first one in interrupts. I want you to be like familiar with interrupts. So now I'm going to show how can I do the sim program, but in C language. So as you see here, guys, in C language, number 1. So here. So I have 2 subroutines, as you see here, guys. Very simple. I just got the 2 subroutines. I'm gonna put, as you see here. This subroutine is number 7. Number 7 is for Archi, right? This is number 6 for IRQ. So this is for IRQ. This is for Archi. For Archi here, nothing is new. This is similar to what I have taught right now. I define a variable. I call it text, as you see here. So every time there is 1 interrupt, I increment text. Every 97 interrupts, I'm gonna flip the LED, and then I'm gonna clear text. Please don't forget this one. If you forget this one, for sure your program is not gonna work. If you forget this one, if you forget to clear the Archi flip, your program is not gonna work. Believe me, this is just simple mistakes are gonna, if you don't pay attention to these mistakes, they are gonna cost you hours. Because you don't know what's wrong. You are not going to think about, if you know, this is how this course is. You are going to spend too much time to look for the mistake. Once you find the mistake, you are going to clear, you are going to correct, you are going to do it quickly. Okay. So don't forget to put this one. Okay. This is for Archi. Now for IRQ, as you see here, guys, the way I'm going to do here in IRQ is, if interrupt is on, I'm going to make them off. If they are off, I'm going to make them on. Right. So how can you do it? One way, you can do it like assembly, like what I did here in assembly. You can just flip one bit. You can do something like that, or you can use function as I did here. So we have two functions. One function is called Rti enable, and we have another one is called Rti disable. So this function is to enable RTIs. This function is used if you want to disable RTIs. Is that okay? So now I need to know if RTI is enabled, so I'm going to disable. If it is disabled, I'm going to enable. So how I can know the status of RTI? How I can know if RTI is enabled or disabled, right? It's the same thing you did in the last lab. You remember last lab? If the cursor in line 1, go to line 2. If it's line 2, go to line 1. Same thing you did also in the last lab. If the L3 is on, make it off. If it is off, make it on. So what did you do? Remember, I used a variable. This variable should have two. This variable should have two values, one for on, one for off. That's exactly what I did here. So what I did here, I used a variable. This one, I call it status. You can call it any name. So if this status is 0, that means it is off. So that's why, as you see here, guys, every time I press the button, so I'm gonna come here. I'm gonna check the status. If the status is 0, I'm gonna make it 1. And then I'm going to enable. So 0 means it's off, means RTI is off. So I'm going to make it on, right? Same thing here. If it is 1, so I'm going to come here. Let me clear this one. So I'm going to come here. I'm going to execute this part. If its status is 0, I'm going to execute this one. If its status is 1, right? So exactly what happens is that when you press one button, I'm going to come here. Next time, you're going to come here. So you are going to alternate between them. So one time here, when you press the button, next time I'm going to be here, next time here, next time here. You got what I'm saying? Because every time I press the button, I'm going to change the status from 1 to 0, 0 to 1, 1 to 0, 0 to 1, right? That's why every time you press, one time here, one time here, one time here, one time here, and so on. Okay. That's why, as you see here, again, this is one way to do it. Okay. So what I did here, guys, as you see, I'm going to use a variable to tell again, and this variable has to be global this way. It has to be global so that after I leave the subroutine and I come back, I find the same value. I'm going to capture the same value. Okay. So that's why if it is 0, so I'm going to make it 1 and enable, right? And if it is 1, I'm going to come here to make it disable. Okay. This is for debouncing, as I explained last time, for debouncing. If you don't write the code of debouncing, listen to me. This is also maybe something interesting. You can try tomorrow. You can remove the code for debouncing. I told you why you need debouncing. Remember last time? Simply because when you press the button, I'm expecting a signal like this one. Actually, you are not going to get a signal like this one. You are going to get a signal has some noise this way. So there are some noise here. Okay. Not noise. It's like bouncing or ripples. On off because of the mechanical parts. So if I connect it to IRQ, so actually when you press one time, you are not gonna make one interrupt. So I'm gonna make multiple interrupts. Okay. So you can try it tomorrow. Just don't write the debouncing code and see what's gonna happen. By the way, maybe when you remove this code, maybe it's gonna work. And you are telling me you told us it's not gonna work, but it's working. You know why? Because as I'm gonna explain in chapter 3, there is what we call hardware solution to the bouncing problem. So I'm going to come, maybe for sure in the old boards, the blue ones, I think most of you don't have this one, but for the old boards, I'm sure there is no hardware solution. Okay, that's why we have bouncing here. So you can try it. If it works, it means the board has a hardware solution. In this hardware solution, we put a capacitor. I'm going to explain how when you put a capacitor, what this one is going to do. Okay, but if you have a hardware solution, you don't need to write a software for debouncing. Anyway, I'm going to explain. Any questions? I think the coming lab should be very easy. Now, any questions? Okay. So now I'm gonna go back to chapter 3. Where okay. So here in chapter 3, guys, I didn't teach some some stuff here. I'm gonna come back and teach them. I told you I had to jump to chapter 4 because I need to teach interrupts first for the lab. Okay, but that's okay. And now I'm gonna teach some parts here. Like the first thing I want to teach here, guys, is the 7 segment. This part, 7 segment here. Okay, as you see here on this board, we have 4 7 segment. As you see here, 4 7 segment. I want to teach them. I'm going to teach how can you program the 7 segment here. Is that okay? How first? What 7 segment is? What is the 7 segment? Okay, I'm going to tell you what is the 7 segment, guys. We call it, as you see here, 7 segment. Okay, so you call it 7 segment because we have 7 segment. 7. This is one segment. I'm going to call it segment A, segment B, C, D, E, F, G. Is that okay? So we have 7 segments and we have 1 dot here, 1 dot. So anyway, we have 7 segments. That's why this one is called 7 segment. Is that fine? So very simple. As I'm going to teach right now, you will find the way you are going to program the 7 segment is going to be almost the same way we programmed the LEDs. It's the same way. You know why? I'm going to tell you why. Because every segment here is one LED. You got what I'm saying? So yes, we have 7 segments. Every segment here, it should have one, it's connected to one LED. So for example, this is segment A. This is one LED, segment B. All of them are connected to the ground this way. Very simple, right? So if I want to turn this segment on, I have to put one here. If I want to turn this segment on, I have to put one here. Very simple. You got what I'm saying, as we'll see. And so let me make it very simple. Very, very simple. Every segment here, guys, is one LED. And every segment is connected to one pin on port B. In port B. So for example, this one is connected to PB0, PB1, and so on. Very simple. So if you want to turn this one on, I have to put one here. If I want to turn this one off, I have to put 0 here, and so on. Is that okay? So make it very simple. So very simple. This is a microcontroller. We have here port B. Every bit is connected to one segment. That's it. That okay? So now look at these numbers here. Look at these numbers. If I want to make number 0, what should I do? If I want to make, so I have to turn the A on, B on, all of them on, except G has to be off, right? So that means it has to be 1 1 1 1 1, as you see here, 0. So this number should be 3F. So I have to put 3F on port B to display number 0. Very simple. Code. So every number has a code. If I wanna put this number on the 7 segment, just to put this code in port B. That's very simple. Okay. Same thing. If for number 1, as you see here, guys, for number 1, all of them are off. 0 means off. So every pin there is a segment. Segment is connected to this pin. If I put 0 in the pin, I turn it off. If I put 1, I turn it on. Is that okay? So that's why if you want to make number 1, I have to put C and B. C and B should be on. Everyone else should be off. That's why the 06, a code. Same thing for all numbers here, for all numbers. So every number you want to put it here should have a code. You should know this code. Okay, guys, very simple. So all what I have to do, very simple. All what I have to do, guys, if I want to display number 0, okay, I have to send this code to port B. That's it. If I wanna display number 2, this is number 2. If I want to display number 7, it is this one. Number 9, it has to be this one. That's it. So every number has a code. You need to know this code. Just send it to the 7 segment. Is that okay? That's it. Now, as I'm gonna teach now, the first program is a very interesting program. In the first program, I want to make counting 7 segments. So I have 1 7 segment. I needed to count 0, and then 1 delay 1 second, 1 delay 1 second, 2, 3, 4, counting until 9. After 9, it's gonna go to 0. You got what I'm saying? So how can you do that? I'm going to tell you how. So let me show you the video first. Sorry, it should be chapter 3. Just give me 1 second. I'm going to teach it next time, but let me show the counting 7 segment. I'm going to show it. Look here, guys. Number 2, number 3, number 4, every second. So I change the number every 1 second, like a timer. Number 7, number 8, number 9. After 9 is going to come 0, and then 1, 2, 3, and you got what I'm saying? So how I can do it simply, I'm not going to explain it, but just to finish what I want to say, just in 1 minute. Look here, guys. How I can do this very simply. Okay, very simple. I told you what I'm going to do. I have these numbers here. So I'm going to output this one to port B. Wait 1 second. Then output this one to port B, wait 1 second. Then output this one to port B, wait 1 second. And that's it. So the way I'm going to do it, as I'm going to explain it next time, I'm going to make array. I'm going to make array this way. Then I'm going to have a pointer here. I'm going to take this one. I'm going to say, go to port B, wait 1 second. Then the pointer is here. Go to port B, wait 1 second. Then the pointer is here every time. So every time I increment the pointer, you got what I'm saying? Take one value, send it to port B, wait 1 second. Once I come to here, so I have to reinitialize the pointer back here. Anyway, I'm going to explain it next time. Okay, guys?